Hey everyone. So we just ended class, and still fresh in my brain, so I wanted to get it on paper, metaphorically, right away. So in this video, I'm going to talk about three big things. We're going to do that 9-1 example that I totally goofed up. It's going to work so much better now, I promise. And then it's another example for you guys to kind of just make sure you have it down. The second piece is the logistic growth particular solution derivation. It's going to be kind of long. I'm just going to be honest, but it's really cool how it works out, and it actually shows you where the formula comes from too. So, and then the last part is logistic growth. We're going to do one more example from the textbook about moose. It's actually example 2. So you technically don't have to watch it or watch this if you don't want to, but definitely want to go through another example with that with you guys. So let's get started. 9-1 example. It was supposed to be dy over dx is equal to, let me just double check this time and make sure it's I did this right. It's negative x over y with the initial condition f of 0 is equal to 4. All right, so yeah, just for this part, remember we have to separate all the variables to the left and right, make sure they're all different, and then integrate and plug in your initial condition. So why don't we do that? So step 1, separate variables. All right, so I'm going to put all the x's on the the right side, all the y's on the left side. So this becomes y dy equals negative x dx. So that was step 1. And then step 2 is the integration step. Don't hate, integrate, right? So we're going to integrate both sides, and we get negative x squared over 2 plus c is equal to y squared over 2, right? I explained in class why the left side you don't need a plus c, right? It's because we just move it over. So step 3, so this is kind of like the optional part. You can plug in your initial condition now, or you can solve for y. So it's kind of like it doesn't matter which order you go into, you will get to the same answer, I promise. All right, so step 3, I'm just going to plug in my initial condition now. It was 0, 4, right? So you're going to plug in the initial condition now, and you get 4 squared over 2 is equal to 0 plus c. And so c looks like 8. And then step 4, plug c in and solve for your particular solution. So I'm going to plug c in. So we get y squared over 2 equals negative x squared over 2 plus 8. And once again, it does not matter if I plugged in that previous step or afterwards. Okay, you will, I promise, get to the same answer. We multiply everything by 2. And actually, you know what? I'm gonna tweak it a little bit. I know you guys are tempted to just take the square root, but I'm gonna write it a different way, so it's a little clear here. What is that? That looks like an equation of a circle with radius 4, right? That's the equation of a circle centered at 0, 0, radius 4. If you remember from class, I showed you guys it was a bunch of concentric circles. This one, not negative y over x, but negative x over y, right? You get a bunch of concentric circles, and we have just found one particular circle with the radius of 4 with the help of our initial condition, okay? So, first part's done. Second part, we're talking about 9-4, and the thing I wanted to show you guys was this guy right here. So we kind of have an intuitive understanding of this formula, right? Kp m minus p, right? We said it came from the exponential formula, and but just with that limiting factor, this m minus p. Well, how does this get to m over 1 plus ae to the negative mkt. Oh my gosh, right? How does that become that? Well, we can actually kind of prove it, and it's gonna take up some space, so you've been warned, all right? So watch. This is a separable differential equation, isn't it? I can move all my p's to one side, all my t's to the other side, and just kind of integrate that way. So watch. I'm going to move anything with a p in it to the left side. So I get dp over p times m minus p. Remember, m is a number. It's your carrying capacity. It's the highest, whatever, amount of things you can have in your whatever you're talking about, right? And then I'm going to move the dt to the other side. I'm going to leave k alone, all right? I could leave it on the left side, but for the sake of this, we're just going to leave it on the right side, okay? So we do our integration step because everything is by itself, right? All the variables are on one side. Let's take care of the easy side first, the right side. So the right side becomes kt plus c, right? Because we're talking about t, and then a plus c always comes out. The left side, okay. The left side looks really, really, it should look familiar. In fact, I'm gonna write it over here. dp over p times m minus p. Does anything call out to you? You know, feel free to pause the video and just like think about it and try it yourself if you see it. Okay, if you don't, you can unpause and yeah. All right, but try and. I'll give you a hint, right? There's something there, you know, maybe something going on. There's two pieces, and it's a fraction. All right, I'll just say it. Okay, this is it's a partial fractions problem. Believe it or not, it's a partial fractions problem where one of the parts is p and the other part is m minus p. So what are we gonna do? We're gonna rewrite the partial fractions into two fractions. So it's gonna be a over p plus dp. The integral of b over m minus p. And this should look familiar, right? Because we just learned how to do this. We just learned how to do partial fractions. So let's try and solve here, all right? Let's see what's going on. You know what? I'm going to ignore the integrals for now because we just want to, the whole point of it is just to rewrite the integrand, right? So let's see if I can solve for a and b with this p and m stuff, right? So what was the first step that we did? Well, if you remember, we multiplied everything by the common denominator. So this is going to become a times m minus p plus bp. Okay? And then now we got to solve for a and b by picking smart values of p. Right? This should sound familiar, right? So I'm going to pick my first smart value based on this. I'm going to let p equal m. And once again, I'm going to go back. What is m? M is a constant. It is your carrying capacity. It will not change in your problem. Okay? So if p is equal to m, that means the a gets canceled out, and it means that I'm left with this, or b is equal to 1 over p. My next smart value of p is going to be 0, right? Let p equal 0. If p equals 0, then the b gets canceled out, and then I'm left with 1 equals am. A is equal to 1 over m. Oh, I just realized b should be 1 over m. Sorry, because we plugged in m for p. Oh, me and my mistakes. So what does this mean? A and b are actually the same value, 1 over m. So if we go back to our integral, all the way over here, right, I can rewrite this as two pieces. It's going to be integral of dp over p with 1 over m, and then plus the another 1 over m, integral of dp over m minus p. All I did was I rewrote using the proper a and b values, right? I pulled the 1 over m's out of the integral. And we have something that we can integrate, right, in terms of p on the left side. This first piece looks like 1 over m ln of absolute value of p plus the second piece becomes another 1 over m. Now, you got to watch out. This is super duper tricky. You get ln of absolute value of m minus p, but because of that minus sign, we have to account for a chain rule which causes a negative to come out. Oh, I know, right? It's crazy. The right side stays exactly the same. We didn't really do anything to the right side. And now, all right, at this point, we're like, we're like, wait, what did we just do? Well, I don't remember. What are we doing? Right? It's like we did all that work. Look at all that beautiful work to the right, and then we came back and we're just like, what the heck is going on? What are we doing again? We are solving for p. We need p by itself, right? Remember, we started with here, and we want to get to here. We're solving for p. We're looking for the particular solution. Okay, all right, now I remember. Let's try and see what we can do here. I'm going to multiply everything by m, okay, because I want to get rid of that m. So m times everything gets me ln of absolute value of p minus ln of absolute value m minus p is equal to mkt. And then the c is just going to be another c value, right? Because it's just multiplied by a value. So I'm going to get mkt plus cn, and hopefully you see, right, that maybe, right, that's where that mkt comes from. All right, so we got that mkt. On the left side, we're going to use log rules. If you don't remember, look it up because they are very important. We're going to combine the left side into one log and get p over m minus p, absolute value, yada, yada, yada. And then how do we get rid of logs? Well, we learned in class today, or refreshed ourselves in class today, that we set the base as e, leaving you with p over m minus p. The absolute values can just kind of go away. And you get e to the mkt times a, right? Because I explained it in class. This is e to the mkt times e to the c, right? And we said e to the c is a. Okay, so for this this next part, it gets a little weird. All right, I'm just gonna say it now. Everything I do, or this next step, I'm going to do for the sake of making it look like what we learned in class today. Okay, what I mean by that is, I'm going to flip this fraction here, which means I have to flip this guy. All right, so watch what happens. I get m minus p over p equals 1 over, now when I flip, right, that's the same thing as raising it to the negative 1. And if I do that, that's this, right? So we can actually kind of just leave the a alone because it's still going to be like a constant. It kind of like holds its value of a, you know? And then the rest goes e to the negative mkt, and that should hopefully explain where that negative mkt comes from. All right, I hope that made sense and was good enough. But yeah, moving on, we get m over p minus 1 is equal to 1 over ae to the negative mkt. From here, it's gonna get a little messy. We're gonna do m over p equals. So when you add this one over here, right, you can combine them, and man, there's got to be a much better way to do this. Over. I guess it would be plus 1 over ae to the negative mkt. And then, what do we do here? And then, what are we doing? We're solving for p, right? Yeah, so you can flip everything again. Oh my gosh. Is equal to ae to the negative mkt over 1 plus ae to the negative mkt. And then multiply by m. And you get p of t is equal to ae, all that nonsense, negative mkt times m all over, 1 plus ae to the negative mkt. And then you can divide all the terms by ae to the negative mkt. And that should get you e to the... Maybe this was supposed to be positive. Man, like I said in class today, I am just not on my game today. But I think I might have missed a negative somewhere. AE to the negative mkt, which gets you m over, right? This becomes 1, right? So it's 1 plus ae to the mkt. I definitely missed a negative somewhere. Damn it. Ugh, so damn close. I maybe if someone can find it for me. But I definitely missed a negative somewhere. Damn, this was supposed to be much more cooler. Sorry. But at this point, I don't want to redo this whole video because my video editing software skills are just not there. So, but yeah, something happened. Something happened with the negative. I know for sure it was a negative issue. If anyone wants to actually find it, I'm sure I'll give you like extra credit or something. I don't know. All right. And the last thing I wanted to talk about was example 2 in section 9.4. I think they say deer. Sure. I think they use deer, not moose. Sorry, I misspoke before. So they said a deer population grows logistically, right? So like they phrase it in the problem. It grows logistically, not exponentially, right? So you know that dp over dt, like this formula is being used, or any other variant of that formula, right? So if it's growing logistically, they say k is equal to 0.4, and they actually tell you what the carrying capacity is. It's 1,000 deer. Oh dear. And in the first part they say, find the deer population. So we're looking for PFT. If the initial population is 100, so you start off with 100 deer, and they give you the initial amount. So we use the formula, right? Hopefully you guys are good at memorizing at this point. PFT is going to equal your carrying capacity, 1,000, over 1 plus A, which is based off your initial, e to the negative m k, which is 0.4, t. And then and now we can plug in our initial condition. So at time 0, it's 100 deer. So at p of 0, we get 1,000 over 1 plus a e to the, looks like 0, because if I plug in 0 in for t, it looks like it's going to be e to the 0 or 1, and that is 100. And we just solved this guy, right? So we kind of did like something like this in class. So we get 1,000 over 1 plus a is equal to 100, or if I do some multiplication and division, it looks like 1 plus a equals 1,000 over 100. So a looks like 9. Right? So I have my a value, and now I can find my p of t. It's 1,000 over 1 plus 9 e to the, what is it, negative 1,000 times 0.4. Oh my gosh. So that's 1, 2, 3, so 400 t? Did I say that right? So 1,000, so 1, 2, 3, yeah. So negative 400 t. And that's it. That's your p of t. The second part of the question goes, how long does it take for the population to reach 500? Right? How long? So they're asking, what is the t value to get the population to be 500? Well, this part, it looks like you're going to need some good old algebra here. So we plug in 500 as the output, and we use our particular solution that we found in part A. And we see what we get. So I just got to solve for t here. Looks like this is 2 equals 1 plus 9e to the negative 400t. Right? I just multiplied both sides by the denominator and divided both sides by 500. Right, okay, just double checking my algebra here. We get 9e to the negative 400t is 1, and 1/9 is equal to e to the negative 400t. We ln both sides, don't need absolute values. Negative 400t, and t is ln of 1 over 9 divided by 400. Time, I think they go by years, so years. And you can leave your answer in that form. All right. So that's pretty much it. If you guys want to see more examples or whatever, I'll take a look at that survey that I sent out. Hopefully you guys were honest in that survey. So yeah, if you guys have any questions or whatever, please reach out to us and we'll help you out. All right. Good luck on that quiz, and I'll see you guys on Friday.